You've already met quadratic polynomials, the x-squared stuff. Set 1 equal to 0, and you get a quadratic equation, the kind that hides inside real problems, like find the dimensions of a hall with area 300. Today, we'll spot a quadratic equation even when it's in disguise, and crack it the cleanest way, by factorizing. Let's go. The plan. First, what a quadratic equation actually is and how to build one from a word problem. Then, how to check if a messy-looking equation is secretly quadratic. And finally, the factorization method, splitting the middle term to find the roots. Slow and clear. Start with the definition. A quadratic equation in X is any equation you can write as a x squared plus bx plus c equals 0, where a, b, and c are real numbers, and crucially a is not 0. If a where 0, the x squared term vanishes, and it's just linear. That x squared is what makes it quadratic. And when the terms are written in descending order of powers, x squared, then x, then the constant, that's the standard form. So 2x squared plus x minus 300 equals 0 is in standard form. Always tidy an equation into this shape first. Where do these come from? Real problems. Say a hall has area 300 square meters and its length is 1 meter more than twice its breadth. Let the breadth be x, then the length is 2x plus 1. Area is length times breadth, 2x plus 1 times x, which is 2x squared plus x. Set it equal to 300. 2x squared plus x equals 300. Move everything to one side. 2x squared plus x minus 300 equals 0. There's your quadratic equation, straight from the words. Now a sneaky skill, deciding if an equation is even quadratic. The trick: simplify first, then look. Take x minus 2 all squared plus 1 equals 2x minus 3. Expand the left. X squared minus 4x plus 4 plus 1, which is x squared minus 4x plus 5. Bring the right over. X squared minus 6x plus 8 equals 0. That's a x squared plus bx plus c form. So yes, quadratic. But watch this one. X times x plus 1 plus 8 equals x plus 2 times x minus 2. The left is x squared plus x plus 8. The right is x squared minus 4. The x squared terms cancel, leaving x plus 12 equals 0. Just linear, not quadratic, and here's the twist. Something that looks cubic, like x plus 2 all cubed equals x cubed minus 4, can simplify down to a quadratic. So never judge by appearance, always simplify first. Now, to solving. A root of a quadratic equation is a value of x that makes it equal 0, exactly the same thing as a 0 of the quadratic polynomial. And since a quadratic has at most 2 zeros, a quadratic equation has at most 2 roots. The cleanest way to find them when it factorizes is this. If the quadratic equals a product of 2 linear factors, it's 0, exactly when one of those factors is 0. So we split it into factors and set each one to 0. Let's do it on 2x squared minus 5x plus 3 equals 0. We split the middle term minus 5x into 2 pieces that multiply to a times c, that's 2 times 3, which is 6, and add to minus 5. Those pieces are minus 2x and minus 3x. So 2x squared minus 5x plus 3 becomes 2x squared minus 2x minus 3x plus 3. Group them, 2x times x minus 1, minus 3 times x minus 1, which factors to 2x minus 3 times x minus 1. Now set each factor to 0. 2x minus 3 equals 0 gives x equals 3 over 2. X minus 1 equals 0 gives x equals 1. So the roots are 1 and 3/2. That's the whole method. One more case. Sometimes both factors are the same. If a quadratic factors as something squared, then setting it to 0 gives just one value, but we call it a repeated root, counted twice. For example, if it factors to 2x minus 3, all squared equals 0, the only root is x equals 3 over 2. But it's a double root. So at most, 2 roots includes the case where the 2 roots are equal. Okay, quick problem to test yourself. It's on screen. You'll get 10 seconds. Pause if you need longer. Split the middle term. Minus 5x is minus 2x minus 3x, and they multiply 2, 6. So it factors as x minus 2 times x minus 3 equals 0, giving x equals 2 or x equals 3. The roots are 2 and 3. That's option A. Your challenge, it's on screen. Pause, simplify, and drop your answer in the comments. I read every single one. So now you can spot a quadratic through any disguise, build one from a story, and solve it by factorizing. But what if it won't factorize nicely? That's next video, the quadratic formula. One formula that cracks every quadratic, plus the discriminant. A one-number test that tells you how many roots there are before you even solve. That's where it gets powerful.